Factoring. Factoring is the reverse of distributing. You have your general form of a quadratic equation, ax squared plus bx plus c, and that's going to equal 0. When you have a quadratic and it's set equal to 0, you're trying to figure out what x is to find the solution to the equation. So when I'm looking at the general equation, at first I'm going to assume that a is a 1, so I always have just the x squared out in the front. But what I want to do, again, this is a review on factoring. If the two signs in the middle are plus plus, the two signs in the parentheses are plus plus. But more importantly, the way you get b is you take the factors of c and you add them. If you have a plus minus, it's also a plus minus in here. The factors of c will be subtracted. Minus plus is minus minus. Factors of c are added. Minus minus is plus minus. Factors of c are subtracted. So the factors of c are added when the signs are the same in the parentheses. And that happens when you have a plus c. Let's look at a couple examples here. X squared minus 12x or minus x equals negative 12. The factors of 12 are 1 times 12, 1 times 12, and 3 times 4. First thing I want to do is figure out which factors I'm going to use to make b. But what I need to know for sure is when I'm making b, am I adding the factors or am I subtracting the factors? And if I look at the signs, minus minus, minus minus, it's right here, plus minus in here, the factors of c are subtracted. So if I subtract 12 and 1, I get an 11. If I subtract 4 and 3, I get a 1. So b is a negative 1. That's what I need. So I'm going to choose the 3 and the 4. And since I need a negative 1 on b, I'm going to take the bigger factor and make sure that goes with the negative sign, or the negative sign in the parentheses. So the bigger factor out of 3 and 4 is 4. So I want to make sure that that goes with the negative. So it's going to be plus minus. Here's my plus minus. I do x times x, because that always gives me x squared. The last positions are for the factors of c. So I'm going to do 3 and the 4, make sure the 4 is with the negative, and then I can just check it. X times x is x squared. X times the negative 4 is negative 4x. 3 times x is 3x. 3 times a negative 4 is negative 12. Combine the middle terms, and you get x squared minus x is minus 12. That works out. But since this is equal to 0, I'm now going to use the zero products rule. When you have two things multiplied, one of them has to be a 0 if the answer is a 0. So you take x plus 3, set that equal to 0, take the x minus 4, set that equal to 0, and solve. The first one you subtract 3, and you get x is a negative 3. The second one, you're going to add 4, so you'll get x is a positive 4. So the answers are negative 3 and positive 4. One thing I want to point out is that when you have the signs here, like the plus 3 over here and the minus 4 here, notice that these are opposite, right? They're not the same. So just don't go fast and say, well, it's 3 and negative 4. Still got to solve it out. All right, let's try another one. X squared minus 4x plus 4. So I have a minus and a plus. A minus and a plus is right here. So that's going to be a minus and a minus. The factors of c are going to be added. All right, so I set it up, minus and a minus. I look at c. It's either a 1 times 4 or 2 times 2. Since I know I have to add them and make a 4, it's got to be the 2 times the 2. They're both negative here, so it doesn't matter where I put them. And as long as I get my x squared and my plus 4 from the first terms and the last terms, I can just check the middle terms to make sure b comes out. So minus 2x adds up to make a minus 4x. And now, because it's equal to 0, do the zero products rule. So x minus 2 equals 0, x minus 2 equals 0, add 2, add 2. Notice how you get the same answer. You don't write it twice. It's just one root. It's a double root. It's just 2. Let's take a look at one where a is not a 1. So if I have 2x squared plus x minus 15 equals 0, the factors are multiplied by the factors of a. Then they're subtracted to make b. How do I know they're subtracted? This is plus minus. If I go back, plus minus inside, it says they're subtracted. But they're going to be multiplied by a as well. So not only do I have to write out the factors of 15, which is 1 and 15 and 3 and 5, I also have to write out the factors of a, which is 1 and 2. So if I put a 2x and an x, right, 2x times x gives me my 2x squared. Now it's just a matter of me saying, is it 1 times 15 or 3 times 5? Chances are it's 3 times 5. It's hardly ever this one. So I'm going to put them in random order. I'll just put the 5 here and the 3 here. So the A factors go first. The C factors go second. So 5x times x is 5x, minus 3 times 2 is minus 6x. So when I add these up, I get a minus x, which isn't right. I mean, the number's right, but I need a plus, not a minus. So all that means is instead of this being plus 5 minus 3, it's going to be minus 5 plus 3. So I switch the signs around. Now I have a minus 5x plus a 6x. There's my plus x. So again, the zero products rule. Take the 2x minus 5, set that equal to 0. Take the x plus 3, set that equal to 0. The first one, I add 5 to both sides. Then I have to divide by 2. So I get a fraction, 5 halves. This one here, I'm going to subtract 3, and I get a negative 3. So my roots are positive 5 halves and a 3. Notice whenever you have a here, one of your roots ends up being a fraction. Difference of two squares. You recognize difference of two squares because there's just two terms, first of all, and they're both perfect squares. So x squared is a perfect square of x times x. 16 is a perfect square of 4 times 4. So the setup for this is add the perfect squares, subtract them. So it's going to be x plus 4, x minus 4. That's what I have here. Take out your zero products rule. X plus 4 equals 0. X minus 4 equals 0. Subtract 4 on this one. You get a negative 4. Add 4 on this one. You get a positive 4. Another way you can factor is by completing the